My name is Nolan Bredesen. I'm going to be talking to you about anteaters today. There are 4 extant species of them, and from left to right, that is the giant anteater, the silky anteater, the northern tamandua, and the southern tamandua. There are other things that people typically call anteaters, but they are not what's generally considered anteaters proper. So more to that point, we'll start by discussing phylogeny. Without getting too in-depth with what some of these terms mean, they belong to domain Eukarya, kingdom Animalia, phylum Chordata, class Mammalia, and superorder Xenarthra, suborder Pilosa, and I honestly forget what category this is, but Vermilingua, it's fine. Within anteaters, there are 2 different families, Cyclopedidae, which are your silky anteaters, and Myrmecophagidae, which are the giant anteaters and the northern and southern tamanduas. Order Pilosa has them monophyletic with sloths. So as you can see here, this overall chart represents Order Pilosa, and you can just see that they branched off into their 2 different lineages. So they're really closely related to the sloth family, and yeah, superorder Xenarthra also includes tree sloths and armadillos, which aren't pictured here because, of course, they're not part of Pilosa, but they are closely related to this order. And also, as you can see, Tamandua, they don't really have their own separate branch because they're really closely related. The northern and southern Tamandua, they're almost not even a different species, but they are. Just another note on phylogeny. They are also related to extinct species such as the Megatherium, which are the giant ground sloths, and the Glyptodons, which are those kind of like armadillo-y looking things. Pretty interesting stuff, especially I think the giant ground sloths are really interesting, just interesting American megafauna type deal. Just a quick note on convergent evolution, just a similar note to what I had said earlier. There are sort of anteaters proper, which are all closely related to each other, and there are things that do ant-eating, and the term for that is myrmecophagy, and that's just roughly Latin translated to ant-eating. And the reason this comes about is because it's species that do ant-eating are in a similar niche throughout different environments across the globe, but they're very unrelated. So it's an example of convergent evolution where different evolutionary lineages find similar niches and end up developing similar traits like long tongues, long snouts, good digging claws, good smell. I don't know if I mentioned that, but some examples of these species are the numbat, the pangolin, the echidna, and the aardvark. So that's kind of convergent evolution. Some people would sort of call these anteaters, but not really, not in terms of phylogeny. But just kind of an interesting tidbit there. So as far as essential anatomy and physiology, some of this isn't too surprising. Some of this is just kind of your bare bones things for Animalia or Mammalia, or however specific or general you want to be with it. So no surprise, lungs, invaginated gas exchangers are the model air breathing organs in animals. So not too surprising there. Giant anteaters are heterotrophs, which is a distinct characteristic of Animalia. And specifically, they can eat up to 30,000 insects in a single day. and we'll kind of get more into that later. More about their anatomy and physiology, just the essential parts of it. Again, none of this is too terribly surprising as far as mammals are concerned. But giant anteaters, and just quick side note, a lot of the research around anteaters in general relates to giant anteaters. So a lot of what I'll be talking about is giant anteaters, but some of this can kind of cross over into the other species, but they're just not as, there's not as wide of a body of research on them. So the main focus will be the giant anteater. Anyway, giant anteaters reach sexual maturity at 3 to 4 years of age. They have a gestation period of around 180 days. And they give birth to a single young, and they nurse their offspring. So again, like for, kind of larger mammals, not too surprising. After birth, the young anteater climbs onto the mother's back, where it stays for up to a year. And a young anteater usually nurses for 6 months and leaves its mother by age 2. And you can just kind of see here, and probably better when you're looking at the slides, there's just kind of a baby anteater on the back of the mom there. It's pretty cool. So habitat and ecosystem. We're talking about a largely South American and Central American group of animals. And as far as the biomes are concerned as well, so for giant anteaters, they kind of prefer like a plains grassland type situation, or forested areas based on certain factors that we'll get into later. Giant anteaters and southern tamanduas, again, they're kind of in all biomes within their range in South America, but both types of tamanduas and the silky anteater are primarily arboreal species, meaning, in trees. And so, as I said, semi-arboreal. The northern tamanduas obviously are a bit more northern, southern are a bit more southern as far as South America, North America. And in our map here we have, in red we have Cyclopedidae, which are the silky anteaters, and the Myrmecophagidae, which are all the others, the giant anteater and the northern and southern tamandua. Anyway, habitat and ecosystem, just some more notes on this. As I was saying earlier, giant anteaters can kind of switch in between forested areas and kind of more open areas like grasslands. And the reason they do this is because in hot or cold temperatures they prefer forests, but in more mild temperatures they prefer open areas. And the main reason for this is because they have a reduced ability to thermoregulate compared to other mammals. And so they kind of have to rely a little bit more on the environment to help do that. And as far as, that would be like an example of, abiotic factors influencing their survival. But as far as biotic, they mainly just need ants, and luckily for them, and termites, luckily for them though, ants are a ubiquitous presence in almost every terrestrial habitat, and this abundance makes them a plentiful and reliable food source. So again, that kind of ties back into their convergent evolution, is because ants are so worldwide, it makes sense that multiple different lineages would evolve to specialize in eating them. And as far as doing so, they have adaptations that help them do that. And one of those is the elongated tubular snout that they have. It kind of acts as a conduit for the tongue, and they're able to efficiently penetrate the hardened exterior of ant and termite nests. And their long, sticky tongue is up to 60 centimeters or 24 inches in length, and acts as a formidable tool for extracting insects from their underground dwellings or crevices in trees. And again, that would kind of be more related to the arboreal species like the silky anteater in the northern and southern tamandua. And more about their adaptations. So this essentially 2 foot long tongue is attached to the sternum, and can flick in and out up to 150 times per minute. And giant anteaters can identify a particular species of ant or termite by smell before they rip apart a nest. And they tend to try to avoid the stinging types. And as you can see here, it's pretty low resolution, but this tamandua is flicking his tongue in and out really rapidly. And for anteaters, their tongue attaches all the way back, like at their sternum, pretty much. So you can see how much they've specialized. They've lost their teeth, but they've gained this extraordinary ability to get right in there and eat ants. And so more about this convergent evolution idea between anteaters proper and the similar species in terms of their niche, but not lineage. The similarities between the tongues of vermilingua and other non-xenarthran eutherian myrmecophagous mammals are somewhat general and under close inspection superficial, being an example of different lineages achieving the same morphofunctional adaptations through distinct evolutionary pathways. All that to say, on the surface it looks really similar, but evolution kind of says that they are a little bit different as far as lineage. So that's kind of an interesting thing there. As far as interaction, again, I'll probably say this 100 times in this presentation, they are myrmecophagous, which just means they eat ants and also termites. That's their main, probably relationship in general with other animals, is that predator and prey relationship. Because different species of anteaters don't compete with each other. They feed on different insects, and they're just kind of solitary within their own territories. So even though they kind of have a wide and overlapping spread, on the individual organism level, they tend to kind of spread out and have their own territories that do sometimes overlap. And they are a keystone species, but again, mainly that's related to insect populations. They control insect populations, particularly ants and termites. And so we'll kind of talk about now the challenges they have and just some of the scientific attention around them. Giant anteaters face habitat loss, which is important because they prefer forested areas due to body temperature regulation needs, kind of like I discussed earlier. And despite these issues, giant anteaters are only considered vulnerable, and northern, southern tamanduas and silky anteaters are classified as least concern. So certainly not no problems, but the main one of concern is the giant tamandua, but even then it's only vulnerable. Still not great, but not the most threatened in terms of like classification of like extinction, I guess. More about these challenges in scientific attention. There are multiple nonprofits that look at research tamanduas and see about their conservation. One of these is the Tamanda Institute. It's a nonprofit NGO that since 2005 has been working to protect a unique group of mammals native to South America. So that's your sloths, anteaters, and armadillos. And that's your, of course, order Xenarthra, as I was discussing earlier. Their mission is to ensure that these survivors of over 65 million years continue to exist. So again, they kind of just research them and look at their conservation. And that's all I have for you.